Hi, today I'm going to go over differentiating three different functions using first principles. So first, an overview on derivatives. Derivatives are essentially a way of finding the slope of a function at any given x value. And the equation for finding the derivatives using first principles is f prime at x. This indicates the derivative is equal to the limit as h approaches 0 of f at x plus h minus f at x over h. So this is the equation, and we're going to use it to differentiate various different functions. So first, we're going to differentiate the following function. F at x is equal to x squared. Actually, let's make it a little bit fun. Let's add a constant, 3x squared. So differentiating, how are we going to differentiate it? Well, first, I like to write the equation again, and then whenever I do this, I write the equation again, and then away I go. Don't forget to write the limit part again, because that's very important. And f at x plus h, so that would be 3 times x plus h squared minus 3x squared over h. Expanding this out, we get this. We get 3 times x squared plus 2xh plus h squared minus 3x squared for h. Now let's expand that out a little bit more. Not x, sorry, h approaches 0. Sometimes I mess that up a little bit. 3x squared plus 6xh plus 3h squared minus 3x squared over h. So what we can clearly see right here is these terms cancel out. And we can factor out an h out of these terms. So we can factor out h here. We can actually factor out a 3 if we want to, but I won't do that. 6x plus 3h over h. And then we can cross out those values like that, and we are left with this. The goal of using first principles is to get rid of the h in the denominator. That way we can directly plug in h equals 0 from the limit using direct substitution. So we can do 6x plus 3 times 0 is equal to 6x. And there you go. There's your answer. Now we're going to do another one. This one's going to be a little bit more fun. We're going to do f at x is equal to, we'll do square root of x. And then we're going to rewrite the equation again. F at x plus h minus f at x over h. So, we're going to directly substitute this in. X plus h minus root x over h. Now, how do we simplify this? Because I can't deal with these x terms. I can't do anything. So what can I do? Well, I can rationalize the numerator by multiplying by the conjugate, which is this. You have to multiply the top and bottom by the conjugate, just like that, and we are left with limit as h approaches 0. The square roots cancel out, so we get x plus h minus x, and notice these terms cancel out, just like that. And then we have to write the denominator, sorry. X plus h plus root x. What else do we notice here? We are left with an h there, and we can just cross out these h's just like that. And we are left with this expression. We are left with 1, because the x's cancel out and the h cross out, and we're left with 1 over root x plus h plus root x. So we can now direct substitute h is equal to 0. So we get 1 over root x plus 0 plus root x. This becomes that, which can simplify to 1 over 2 times root x. And there we go. We have our answer. Now let's do one more. This one is going to be a little bit more tricky. Let's do f at x is equal to sine x. So when we differentiate this, lim as h approaches 0, f at x plus h minus f at x over h. I'm going to actually write this a little bit more to the left, so I have a little bit more space. We get sine of x plus h minus sine x over h. What can we do here? Well, if you remember your trig identities, then you will know that you can use the sum equation right here. So we can use sine x cos h, plus sine h cos x minus sine x over h. Now we have sine x cos h and then minus sine x. We can factor out a sine x very easily. Sine x, we get cos h minus 1 plus sine h cos x. And I'm going to do something else. I'm going to split this up into two different fractions. Just like that. You're going to see. Then what I can do is I can split this up into two different limits entirely. Sine x times cos h minus 1 over h. And then plus the new limit, the second limit, which is sine h cos x over h. I'm going to give myself a little bit more space. What I could actually do here is I can bring out the sine x according to laws of limits. So I can bring out the sine x as a constant, and then I'm left with cos h minus 1 over h plus lim h approaches 0. I can bring out the cos x term right here, because we're bringing out the x term and leaving in the h term, sine h over h. So what do we know about these limits? This is a special limit, this is a special limit. This special limit right here equals 0. This limit equals 0. The cos h minus 1 over h equals 0, and then this limit, the sine h over h limit, is another special limit. It equals 1. So this whole thing right here, this sine x, that cancels out because you're multiplying by 0, and you're left with cos x. And that is your answer. I hope you found this video helpful. Thank you so much for watching, and have a good day.